Across the vast stretches of space, we look toward the stars with wonder and curiosity. Among the countless worlds orbiting distant suns, one in particular has captured our imagination: Proxima b. Orbiting the star Proxima Centauri, the closest known star to our own sun, Proxima b lies in the sweet spot of the habitable zone, where liquid water could exist. And yet, though it may seem like a second Earth, its true nature is far more mysterious, more alien than we could ever have anticipated. Discovered in 2016, Proxima b has sparked our imaginations like few other planets. It's a super-Earth, slightly larger than our own, and located just over 4 light-years away, a stone's throw in cosmic terms. It's in the habitable zone of its star, the region where conditions could allow water to remain liquid on the surface. Water, the key ingredient for life as we know it. But though it holds promise, Proxima b is a world that defies easy understanding. For every bit of hope it offers, it challenges us in ways that go beyond anything we've encountered in our search for life. Proxima b is an alien world in ways that stretch our imagination. The star that warms it, Proxima Centauri, is not like our sun. It's a faint red dwarf, much cooler and much smaller, emitting a weak, reddish light. While the habitable zone is in the right place, the conditions that this planet faces are far from familiar. Red dwarfs are known to be violent, frequently emitting powerful solar flares that could bathe the planet in harmful radiation. Would life on Proxima b have evolved to protect itself from these flares? Or would it have found a way to harness the radiation to survive? Could life not only endure in this harsh environment, but perhaps thrive in ways we haven't yet imagined? Proxima b's atmosphere would be anything but tranquil. The planet's close orbit around its star means that one side of the planet is always facing the heat, while the other is in eternal darkness. These extreme temperature differences would lead to violent winds and powerful storms. Imagine a world where the atmosphere itself is in constant turmoil, constant change. A world where, every moment, the battle between heat and cold is waged in a never-ending dance. For life here to survive, it would need extraordinary resilience, finding shelter from these forces in ways that we, as Earthlings, may never have considered. On Earth, we've found life in the most extreme places, life that doesn't depend on the sun at all. In the depths of the ocean, around hydrothermal vents, life flourishes in complete darkness, fed by heat and chemicals rather than sunlight. Could Proxima b harbor something similar? Below its surface, in the dark recesses of the planet, water could exist in lakes or oceans, shielded from the radiation above. Could these hidden, subterranean ecosystems be the cradle of life on Proxima b? And what would life look like in these hidden worlds? Could organisms here rely on geothermal energy, living in total darkness, far from the light of their faint sun? Life in these subterranean waters might be radically different from anything we know. Bioluminescent creatures, perhaps glowing softly in the dark to communicate or attract mates, could populate the depths of Proxima b's oceans. These alien organisms might not even resemble the creatures of Earth. They could be based on entirely different biochemical processes, life forms that metabolize energy in ways we can't yet understand. Perhaps they don't rely on carbon-based molecules like we do, but on silicon or some other element entirely, evolving in ways that break the fundamental rules of biology as we know them. These creatures could have evolved to withstand the harsh radiation of the surface, developing translucent bodies or thick exoskeletons to protect themselves from the harmful rays of their star. With no sunlight to fuel their biology, these organisms may rely on chemical energy in ways that are foreign to us. They might even be able to harness the energy from Proxima Centauri's radiation, perhaps drawing power from its constant flares, adapting, evolving, and finding ways to thrive in a way that defies our understanding. Above the surface, life would face even more challenges. The planet's extreme environments would demand incredible adaptations. The days on Proxima b would scorch the surface with temperatures far above anything we experience on Earth, while the nights would plunge into a deep, freezing cold. Could life find a way to endure such extremes, thriving in a world where the battle between heat and cold never ceases? Perhaps, like on Earth, organisms would learn to use the planet's heat, its geothermal energy, to survive, seeking out the planet's natural hot spots or volcanic fissures for warmth and shelter. In such a world, evolution could favor life forms that are hardy and resourceful, organisms that can withstand both the heat of a constant day and the bitter cold of endless nights. Could Proxima b support plant life? And if so, how would these plants evolve? Perhaps, unlike the green plants of Earth that rely on sunlight, the flora of Proxima b might photosynthesize under the faint red glow of their distant star, using wavelengths of light that we can't even detect. These plants might be small and hardy, able to store water in tough, waxy leaves, protecting themselves from the planet's violent storms. Or perhaps they would draw energy from the heat of the planet itself, thriving near volcanic vents or in the warmth of underground caves. Across Proxima b's rocky surface, strange life forms might skitter and crawl. They may resemble nothing we know, a mix of amphibians, insects, or even creatures more alien. Their bodies designed to survive in this harsh, unpredictable world. Some might scavenge what little food exists, while others could have evolved to survive on radiation, perhaps feeding on the very energy that makes the planet so dangerous. Life here would have to adapt to constant flux, living at the edge of extremes, where only the most adaptable would thrive. Proxima b stands as a reminder of how vast and diverse the universe is. Its potential for life is not limited by the rules we know. It forces us to expand our understanding of biology, of what it means to be alive. As we look out across the stars, we realize that the true beauty of the universe lies in its mystery. Worlds like Proxima b are proof that there are possibilities beyond our imagination. A world full of secrets, waiting to be uncovered. What life, if any, exists there remains a tantalizing question. A question that will push the boundaries of science and wonder for generations to come. And as we continue to explore the cosmos, searching for life beyond Earth, Proxima b stands as a testament to our boundless curiosity. A world like no other, where the limits of life, evolution, and adaptation are pushed to the extreme. Perhaps one day, we will find the answers to the questions we've been asking for centuries. Perhaps we will find that life, in all its forms, is more diverse and more resilient than we ever thought possible. For now, the mystery of Proxima b endures. But with each new discovery, we move closer to unraveling the secrets of this distant world. And in doing so, we might just unlock the mysteries of the universe itself.